So welcome back, and in this video we're going to be going over every single thing that you need to know about paper 2 plus exam questions that I think that may come up. If you don't like paper 2, by the end of this I hope that you do like it and you find this useful. If you did, be sure to like, subscribe and share with everyone. First topic is computational thinking. Decomposition is breaking a problem down into smaller sub-problems. Once each sub-problem is small and simple enough, it can be tackled individually, so as to decompose. Abstraction is to remove or hiding unnecessary details from a problem so that the important details can be focused on. Algorithmic thinking involves deciding on the order that instructions are carried out and identifying decisions that need to be made by the computer. Here's a typical exam question. So Elliot plays for OCR FC. He wants to create a program to store the results of each football match they play and the names of the goal scorers. And yeah, what is meant by abstraction? So abstraction is simply removing unnecessary detail and focusing on the important detail. So that's what we can write for the 2 marks. It also simplifies the problem down for the 2nd mark. And part B is give one example how abstraction can be used when developing this program. The names, we can simplify the names. So instead of showing full name and surname, we can just have the surname, which is the most important part. Now 2.1, we have designing, creating and refining algorithms. Here you have flowcharts, trace tables and pseudocode. So we're going to do exam questions rather than dive into the theory. So make sure you know your symbols and let's have a go at creating a flowchart ourselves. So basically, a fast food restaurant offers half-price meals if the customer is a student or has a discount card. This offer is not valid on Saturdays. So student or has a discount card. The system is used to identify whether the customer can have a half price or not. So we need it to input required data. That's the first thing we're going to do. So remember, to start we need like this shape, and then we need the input, so something like this. Apologize, I didn't do art for a reason. Input discount card. Now we're gonna have a diamond, which is going to represent a decision. Basically, if it's not Saturday is the first condition we're going to be checking. So that means that it is Saturday and we're gonna put out the full price. So if it isn't Saturday, then we gotta check do they have a discount card. So that's the decision we're gonna make here. So if they are a student or has a discount card, we're gonna have half price, which is similar to here. And then we end, which will go over the screen, and also connect this up over here. Also remember that we need a true and a false. So if it's false, we're going to print out half price, and this is true. Alright, so here's a trace table question. Let's have a go at it. So basically, we have to write down the values, the initial values for x and y. So to start with, we have 15, and y is 0, and we don't output anything because that's at the end. So while x is greater than 0, which it is, we're going to add 1 to y. So y equals 1, and we're going to subtract x by y. So we're going to subtract 1 from x, which is 14. Then we're going to go back to the condition x is greater than 0, which it is because x is 14. Y equals y plus 1, increment that by this. And we're going to subtract 2 from whatever x is. So x equals x minus 2, which is 14 minus 2, which is 12. Now we go back here, we increment, so we get 3. Now we subtract 12 by 3 to get 9, and increment this again. So that's going to be 9 minus 4, which is 5. Increment this again. Now be careful here. So x is currently 5, which is greater than 0. So we increment, and then x equals x minus. So this is now equal to 0. Now this condition is invalid now. So we exit here and we print whatever the value for y is, which is 5. This is how you would fill out a trace table. So try and spot a pattern like how we did. So it is just incrementing this until It's the same as this, and then yeah. Alright, the next topic is searching and sorting algorithms, which I have covered in a separate video, so you can click in the description, or if it pops up, you can go watch that one. However, we'll do a quick recap on the sorting algorithms and the searching one. So linear search, well, we have an array, 15, and let's say we want to find v equals 2. And what we do is just start at index position 0. Remember, this is indexed. And we keep going right until it's the same. And that's what we call linear search. So that's basically what the definition is. The pro is that we don't need a precondition. It works for any list, which is a major upside when you compare it to binary search, which we'll come on to next. And however, the con is that you have to check every single item. So imagine you have a data set with 100 items and your item is not even there. So it's going to be comparing 100 times to find the item that you're trying to look for, which is very inefficient. All right, let's look at binary search. So how does this work? It's basically like finding an item in the dictionary. Basically, we start at the middle value, and remember, a precondition for binary search is that it has to be sorted. So we need to have a sorted list. So 1, 2, 3, 4. And we start at the middle. So this is an even, so we take the leftmost. So let's take 2 as the middle. Then we compare it to the value that we're trying to find. Let's see if we want to try and 1. We basically compare it, and clearly it's less than the value that we're trying to find. So we ignore everything to its left, including the middle value. And then we look at the middle. We find the middle of this remaining section, which is, in this case, is just 1. And we compare it to the value that we want, and it is, so we found the item. And the pros of this is that it's very efficient, and if an ordered list of 1 million numbers is used, we'll find it in no longer than 21 comparisons, which linear search would do the same thing in 1 million searches. So this just goes to show that this is a very efficient algorithm. However, it only works with the sorted list. So if you think about it, like, you have to use a sorting algorithm first and then use binary search. I mean, maybe it's the same as linear search. Might as well use linear search because you don't need to use like a sorting algorithm. But yeah, that's something you can say. And let's move on to integer 8 exists in the list of these integers, and explain why it's not found in a binary search. Clearly it's here, but why is it not found? Because remember, it needs to be sorted. So we can say that for binary search to happen or perform, you need to have the list in a sorted order. Also, identify and describe an alternative searching algorithm. We can just describe linear search. So we can use linear search, compares every single value to the value that we want to find, and if it's equal to, we return true, otherwise we return false. We can say something like that. Now let's move on to bubble sort. So how does this work? We compare pairs of values. So if you have 1 and 2, we compare these pair, and if they're in the wrong order, we swap, and if they're in the right order, we move on to the next pair. So pairs is a key word whenever you get asked how to perform bubble sorts or whatever. Make sure you know that. And also, after the first pass, the highest element is list bubbles towards the end, hence the name bubble sort. Again, I've gone through this in the in-depth video. This is just a quick recap. Here's the pseudocode for bubble sort again. So what we do is we do until sorted is equal to true, and we loop through the array. And this part takes care of the swapping. So describe the purpose of temp. Well, we need temp because otherwise our data value is going to get lost when we're swapping 2 elements together. So temp means temporary, and it temporarily holds the data to allow the contents of 2 variables to be swapped, and so that the data is not overwritten. Write that here. And what's the point of having a sorted variable? Well, it signifies whether there's been any swaps made or not. Again, remember, if there's no swaps to be made, it will still run at least once to check that there's no swaps made. So if we've made a swap, we know that it's not sorted. That's what we can say here. Now let's move on to the next sorting algorithm, which is insertion sort. So how does this work? Well, the first item in the list gets put into the sorted list and the rest of the elements get put in the unsorted list. Then we take each element from the unsorted and we insert it in its correct position in the sorted list. So ideally that item gets compared to every single item that's previous to it. The pros are it's more efficient than bubble sort because fewer iterations are needed on average. Little memory use because we're not creating new arrays or something, and it's easy to implement. However, it's not very efficient compared to merge sort, which is the most efficient algorithm that you know for GCSEs. So here is another question, and this is the pseudocode for insertion sorts. Describe the purpose of temp. So again, just like what we said in bubble sort, we would say the exact same thing here. Also part B is there's a nested loop, which you can see here, the for loops here and the while loop is here. So explain why the inner loop needs to be a condition controlled loop. What is a condition controlled loop? It's a while loop. Why do we use a while loop is basically what it's asking in disguise. So when do we use a while loop? Well, when we use it when the number of iterations are not determined. So we don't know how many times it's gonna need. And why do we need it in this case? Why does that help us? Because we don't know when the item is gonna be put in the correct position. It may already be in the correct position, but we don't know that. So that's why we have this condition here, which is name's position is less than the one previous to it. Now, let's move on to merge sort, which uses a divide and conquer approach to split data into individual lists, then merge it back together in order. So the divide stage basically splits it into two sublists and then into two until each of those sublists list is one item long. That's key. Once all of them are in one item long list, then we just put them back together in its correct position. So let's do a quick example. I've done many on my TikTok, but let's just do it here. If we got 1, 2, 10 and 5, you swap, divide it into 2 and then divide it again so that each is its own separate, separate list. So once we get that, we basically put them back together. So 1 and 2 in its correct position, and here we're going to swap these elements, so 5 and 10. And then the last one, we're finally going to have 1, 2, 5 and 10. So this part over here is called the divide, and the last part is called the conquer. This is very efficient. However, it's inefficient for small lists or lists that's nearly sorted. For example, here we could just use an insertion sort that will probably be more efficient than having to split. All right, let's move on to the next topic, which is programming fundamentals. So again, if you're not very strong, go check out all the Python that you need to know. So variables just hold data, and it's like a label, like a name that you give to a piece of data, which you can change during the execution of a program. So first you can assign x to 5, then maybe later down on the program code you change it to 10. That's perfectly possible. However, with a constant, you can't change. So once it's set, it's set. It's like a final variable if you do Java. So variables and constants are given identifier or name, which basically make sure you're using like a proper name. Like that's all to do with like maintainability. Use proper variable names. Don't use names which are like reserved in the programming language. Like for example, you can't create a variable called print because print is a function used in Python. Also, make sure it doesn't contain any spaces or numbers. So variables and constants are assigned values using the equal operator, and yeah. Let's move on to the next one, which is programming constructs. Again, programming constructs are what? They're building blocks that programmers use to write code. There are 3 main types. Just like how a builder needs bricks, cement, and all of that to build a house, us programmers need programming constructs to write code. There are 3. Sequence is basically what everyone does, basically. So statements are executed one after another. So it runs from top to bottom, and each instruction completes fully before the next one is executed. That's sequence. Selection is basically a set piece of code is ran. So that's like if statement. So if this is true, then we run it. Otherwise, we don't even look at the rest. And your switch case statement, that's also an example of selection. Iteration is a construct used to repeat sections of code. Iteration means to iterate, which means looping. There are two main types, count controlled and condition controlled. Count controlled is when we have a defined number of times to repeat, like a for loop. Condition controlled is like a condition, it's based on a condition. For example, when a user types something, and if it types something, we want to stop. If it doesn't write that, we continue looping. So there are two examples, while loop and a do until loop. They are both ways of implementing a condition controlled iteration. Now let's look at data types, 5 main types. So integers are whole numbers, either positive or negative. Real number is like a decimal number, and floats are always sometimes used when precision is required. Boolean only stores true or false values. These are the only things you can assign to a Boolean value. Characters is a single type of character set, for example, the letter A or the @ symbol. String is a collection of characters, for example, hello world is a string and you used like a quotation mark. And casting is conversion from one data type to another. Note that you can't change all of them. For example, like hello world, you can't change that integer. That doesn't make sense. Now, there are additional programming techniques that we can use. So slicing means to extract individual characters from strings. So imagine you want ELL from hello. That's an example of slicing. Concatenation means joining together strings. So concatenation, you just use the plus symbol. So dot length is used to count how many characters there are. Here's an example, substring. Most common problem students have with substring is that you think that X is the start index and Y is the end index. However, it's not. X is the starting, Y is the number of characters required. So 2, 2, we start at index position 2, which is 0, 1, 2, the L, and the character we want is 2. So L is one of them, and the next L is the second one. Dot left is basically all the required characters from the left, and the right is the number of characters needed from the right. And upper is to convert for uppercase, lower is to lowercase. ASCII basically finds the ASCII value of the character, and char basically just does it the other way around. Here are all of the file handling commands that you need to know. So open just opens it in memory. Read line reads a single line of data from contents. Then we write line, which just means writing to a file. Then we close it, and end of line basically returns true if it's the end and false if it's not. So a typical way of doing it is using a while loop or a do until loop. And to print a random number, we basically just random. So here is an example. You might be asked, what does this code do? So random file equals open it. So you open it, and this is the name that you refer to now. So while not the end of the file, while it's not the end of the file, we basically set data equal to one line at a time. So first time, the first line is going to be assigned to data, then we print it. Then the second time, the second line is going to be added to data and we print data, so on and so forth until it's reached the end of the line. And SQL is used to access data in a database. Select identifies the select fields from a database, and we use a wildcard asterisk to mean all fields. From identifies which tables the data will be returned from. So usually you only have one. And where is an optional command that allows programmers to include criteria with only matching records being returned. So here is an example. Hopefully you can see that. Table is called students, which shows, not showing, shows 3 records, Bradley, Cable, Jamie, and so on. We got 4 fields, and we want to basically select the first name and the email of the students where they are in year 9 or year 10. The way that we can do this is using this command, and once you do that, it would show the first name and the email. Let's have an example. So basically we have a database table called results with each student in each of the chosen subjects. Complete the SQL query to return all of the fields for students who take art. So return all means we need all of the fields, and remember we can use the wildcard asterisk, so we would say select asterisk. Then from is always a table. Table name is results, so we say from results, where subject is equal to art, because we're only interested in those that do art. Now let's look at arrays. A one-dimensional array allows the programmer to store multiple items of data under a single identifier. A variable is only allowed one item of data. So if we want multiple items of data, we need to use an array. All items are indexed, meaning that the first item can be accessed using the index position 0. This is the first, this is second, this is 3, and this is 4. These are immutable, meaning that once the size is declared, you can't add items onto it. And items in the array must have the same data type. And how to print all of the arrays out, we would basically use a for loop that goes from 0 to colors.length -1. Why do we -1? Because each item in the array is indexed. So if we do index position 5, 0, 1, 2, 3, 4, the maximum index is 4, not 5. That's why we -1. Then if we print it, this should print blue, pink, green, yellow, and red. Hopefully that makes sense. And let's do an exam question. The number of goals scored for each football match is held in an array called goals. An example of this array is shown here, goals 0, 1, and Elliot wants to count how many matches end with 0 goals. So we start at no count goals score. This is like a counter. Then for count equal to 0 to goals length -1. Now, if goals at position, remember the square brackets, you put in an index position that's inside. So what is equal to 0, then we're going to increment count. If goals at position count, so remember you're using this can be I, this can be J, this can be anything. Make sure you use that. So if goals at position count is equal to 0, then no goals count equals no goals count plus 1. We're going to increment goals count by 1, and we're going to print that at the end. Now we talk about 2D arrays. So what these are basically, they're the same as 1D arrays, except these are arrays of arrays. So before we had variables like 1 variable, 2 variable inside an array. Now we have an array inside an array. So we can store multiple arrays. So in this example, 1, 1 refers to 9. What is 1, 1? 1 is referring to the first index of the array. This is 0, this is 1. Again, if you don't know 2D arrays, go check out my video. It goes through everything about 2D arrays. So if this doesn't make sense, go check that one out. Trust me, you learn 2D arrays so much better if you watch that video. It's a 15-minute video or something like that. Go watch it. So this is how you would find the total of the elements. We use 2 loops, so like a nested loop, and this should be indented, but forgive me for that. However, the first loop goes from 0 to length -1, and then the second loop goes from 0 to the actual scores at position I, so the individual array item length. And then we just add whatever value is onto total, and then we print total at the end. Now let's do an exam question. Data for 1 week, Monday to Friday, is stored in a 2D array called mins played. The following table shows part of the array containing 4 students, and we're told that minutes at 3:02 corresponds to Dan, who's played the games on Wednesday. So where's Dan? Dan is here. The 2 refers to 20. So this should print the number 20. We're asked to write the line of code that shows that Stuart played games on Friday. So from this, we know that the first refers to the column and the second one refers to the row, or the students and the days of the week. So Stuart is going to be at position 0. So instead of 3 here, we're going to have 0, and the 2 over here, we're going to have a 4, so 0, 4. And you basically copy this line, and instead of 3, 2, you write 0, 4. Now we move on to additional programming techniques, which is the use of subprograms. This is sometimes called subroutines, And what's the point of these? These are so because when you're writing so much code, they grow in size and they become hard to manage. Ideally, larger programs should be broken down into subprograms. This is similar to like decomposition, where splitting down a complex problem into small parts. That's what basically functions and procedures do. Those are examples of subprograms. The advantages of using subprograms are they reduce the overall size of the program so that it doesn't need to be repeated in multiple places. So if you have a function to calculate the sum, we can just use that sum calculation everywhere else instead of copying the lines of code. We'll see an example shortly. They also make the code much easier to maintain and read and understand. Also, they improve the maintainability of a program. They reduce development and testing time because the function is going to be already tested. So it's easier to just copy that function any way you need because it's going to be bug-free. They also promote reusability, which is always a good thing. So procedures and functions are types of subprograms. Procedures do not return a value. Functions do return a value. This value then can be stored and used in the main program. We'll see an example. So procedure add, we take in two parameters. We take x and y. So to call this, if we do 1 and 2, we'll add together 1 and 2 and we'll print 1 and 2 added together, which is 3. This is how you do it in pseudocode, and this is how you write a function in pseudocode. So addition takes in 2 again, and this time we can assign a value called x, and you can store whatever the value of this procedure returns. This will return x plus y, so 2 plus 3, which is 5, and it will return that. So x will equal 5, which is not possible in a procedure. If we do x equals add 1, 2, you'll get an error saying you can't assign a value because you're not returning anything. Now we move on to local and global variables. And what local variables are, these are defined in the subprogram and are only accessible only in that subprogram in which they're defined in. For example, total over here is only accessible in this subprogram. If we write total outside the program, it won't recognize what variable total is. It will say total is undefined. Make sure you are comfortable. Local variables are locally defined inside a subprogram. You can't access it elsewhere. Global username is accessible globally, which basically means they exist throughout the whole program, and other subprograms, they can change the value as well. So one difference between global and local: global variables are accessible throughout the whole program. Local variables are only accessible in the subprogram they are defined in. Explain using one example why global variables are sometimes used. Global variables are sometimes used because when other parts of the program need access to that variable, we will use a global variable. And it is the same value irrespective of the place where it's accessed. And what's the benefits of subprograms? Well, once you write a subprogram, they are easy to read, they improve maintainability, they also avoid repeated code because whenever you want to use the subprogram, you can just call it. You can also reuse it. Now let's have a go at writing a function. So a program is created to convert hours and minutes into a total number of minutes. So we convert basically hours into minutes. Now the teacher wants to create a subprogram to perform this calculation. So this is what the function is going to be. The program has been started but is not complete. Our job is to complete it. So first things first, we take the input for hours, then we take the input for minutes. Now final total is going to be a function call to whatever we call this function. So let's have a go. Let's call this function total minutes, and we take in two parameters. We're going to take in hours and we're going to take minutes. What we're going to do with these two information, we're going to now calculate the total minutes using the hours. So how we do this is first create a total variable and we store hours multiplied by 60 plus the minutes. So we're converting the hours into minutes. That's why we times by 60, and then we add this minutes onto it. because to find the total number of minutes. Then we basically return, don't forget to return the total, because a function always returns a value. Once we return this, it's going to be stored here. So what we do here is we call this function called total min, and we give it two parameters. The names must match this. Over here it doesn't need to match, over here it needs to match. So hours and minutes. We take these two numbers and it goes into this function. This function now does its little algorithm magic. We create total variable and we store the amount of minutes. So then we return total and we then print out the final total. Alright, here's another question. This is now to do with combining file handling and functions together. So let's have a read. A library gives each book a code from the first three letters of the book title in uppercase. So first three, we're going to use some string manipulation, and in uppercase, so dot upper is going to be used somewhere. Followed by the two last digits of the year the book was published. So we're going to use some sort of concatenation. And for example, poetry from the war published in 2012 would be given the code POE because it's the first three letters, POE, and in uppercase, and plus whatever the published date is. So we need to complete the pseudocode, so which takes in the book title and years as parameters. So we know two things are going to be sent here. Title is already done for us. Now we just need to do years. Now part A is going to be the substring of the title. We need the first three. So remember from string manipulation, make sure you fix that table in your head. Substring, you start at 0th position, and how many required characters do we need? We need 3. So we put 3 here because we're going to start from P, O, and E. That's 3 characters. Then the year published, we're going to have 2. So starting from 0, 1, and we need 2 characters. So 1 and 2. What goes here? People might think it's print, but it's not print, it's actually return. Make sure a function always returns a value. So we're returning what? We're returning part A dot upper concatenated, joined together with part B, and hence we would get PO12. Use pseudocode to write a algorithm that does the following: inputs the title of the title and year of a book. So what we're doing, we're going to be doing title equals input and year equals input. Then we use the function that we made over here and to work out the code. So because this returns it, we can now use it, and we're going to permanently store this into this text file. So this is joining everything that you know. So firstly, we're going to have title equals inputs. Then we're going to get the year, which is the same thing, input. Then we're asked to find the code. So to find the code, we basically call the function library code, and we need to pass it in 2 things. So title and year. And we're going to name this variable so that we can store it into our file once we open it and do it. So let's just call this data. And now we want to add it to our text file called bookcodes.txt. So in order to write or read, we always have to open the file first, and we call it a name. So my file equals open, and we open this book. So bookcodes.txt. What we're going to do once we open it, we're going to write line. So my file dot write line. What we're going to write line to it, we're going to write line data. Then we're basically, make sure once you open and do everything, make sure you close it. So my file dot close, and that's basically how you would do this question. Again, I've made a separate video on file handling. If you couldn't do this question, go check that one out, then attempt this again, and you should get full marks on this question. Now, 2.3, producing robust programs. So this is your Defensive design. So what is defensive design? It means thinking ahead about problems that could occur and defending against those problems. There are three main ways in which you can defend. Anticipating misuse, which is thinking about ways the users can cause the program to fail. This could either deliberate or accidental on the user's behalf. Authentication is checking for identity of a user. This can be done using a username and password or two-factor authentication or biometrics. And input validation is to check whether the data matches certain rules. For example, this postcode might seem normal, but it's not actually like a proper postcode, so you need to check. Maintainability means how can you maintain the piece of code? So when you're not here and someone else looks at the code, will they know what it's about? That's what we're basically talking about when we refer to maintainability. Ways in which we can improve the maintainability is by using subprograms, because what they do is it splits the complex problem into smaller parts. Also using proper variable names and subprogram names. So for example, not just putting x equals something, maybe put the name of what the data might hold. So for example, total cost, which as you already know, it stores the total cost. Also use indentation, because this is, again, in Python, it requires correct indentation for the program to function correctly. And yeah, commenting also, that's the easy few marks you can already gain by knowing this slide. Two things we can use are, one of them is input sanitation or input validation. Make sure the inputs are valid and check for any errors. Also, we can use maintainable code, which is to allow other programmers to understand and not only yourself. We can maybe also say authentication. So anything that we've mentioned on the previous slide is applicable over here. Testing. The purpose of testing is to ensure the program functions as expected and meets all requirements. Testing should be destructive and aim to find errors, not just to show that it works in one situation. It needs to be checking that it works in all situations. Testing is very, very, very important. Iterative testing means testing during the development of the program. Each module is tested. Final or terminal testing is completed near the end of the program, which is like you're testing the whole functionality. Also, syntax error is one that breaks the grammatical errors and won't run. A logic error is that it will run, however it won't run logically. There are 4 types. Normal testing is like a normal piece of data which a user might put like normal. Boundary testing is if you have like a boundary, like an if statement, like testing the different conditions. Invalid test is something that is accepted limits. Invalid test data should be rejected. For example, in the previous example, we had like a postcode like XX13YYY. If we put that in a postcode, that's invalid. So the program should not crash, but it should say that write a valid postcode. An erroneous test is basically the incorrect type and should be rejected from the system. For example, if it's expected a numerical input, a string would be a erroneous input. Now we move on to Boolean logic, and the NOT gate basically is like an inverter. If we put 0, you get 1 back. If you put 1, you get a 0. Make sure you know the symbol, because even if you miss out this circle, you'll lose the mark. So make sure you know this symbol inside out. Make sure you know and make sure 1 and 1 is gonna equal 1. So that's the only scenario when the AND gate gives 1. All the rest of the scenarios, you get 0. And for the OR gates, either or will give you 1, except when it's 0, 0. So make sure you're familiar with this. And let's have a go at this question. This question has been the most poorly answered question on OCR's exam questions. A garden floodlight system uses input from sensors and switches to decide whether it should be turned on or not. The table shows the input. So A is a motion sensor, and input of 1 means that it's detected, 0 means it's not detected. B is a light sensor, so light level indicates it's daytime, light level indicate is nighttime if it's 0. Then we have a light switch. If it's turned on, that's 1. If it's turned off, it's 0. We're told that the floodlight is designed to be turned on when Q is equal to 1. When the switch is turned on, so C is 1. And, so we're going to be using a AND straight away. The motion sensor detects motion at nighttime. So motion detected is 1 and nighttime is 0. So A and B, so we basically have two things. We have A and B first, and then we have and C. And C. However, these two, if they're 1, that would mean that motion is detected and light time indicate is daytime. So we need to somehow make it into a 0 so that it's nighttime. So the way that we do this is simply just add a not in front of B. So we have A, C is going to be your switch, which is turned on. And remember, this is going to be 1 and this is going to be 1. So if it's 1, 1, we're going to have Q equal to 1. Otherwise, all the rest combination, we're going to get a 0, for which the floodlight needs to be off. So firstly, write down the thing in terms of the symbols. Now you can draw the diagram of this. So we're going to have straight away a not in front of B. So make sure you know your symbol for not. A is going to be just going into a AND. So we're going to have a AND over here. So A goes into here and here. Now we're going to have these two now going into another AND, this AND in the middle or over here. And we have C, which goes to the last AND, so something like this. And again, if you're not familiar with this, there's plenty of questions. Not plenty, but you are around 5 or 6 questions from past papers that you can find on my website. So the last topic is 2.5, Programming Languages and IDE. Everyone should know this topic. Low-level language is basically what computers use. It's like machine code or assembly language, and it uses binary or mnemonics to represent instructions. Hardware dependent, it can only run on specific type of computers only. Our computer, like general purpose computers, can't run it. Also, it's like more so it directly refers to the computer's hardware rather than the programmers to understand how it works. High-level languages like Python, C#, Java, all of those are high-level languages. They use English-like words, so like print, while, if, and they're hardware independent and will run on every single computer. Abstract, the details of the processor, like the behind the scenes are abstract to us because we don't need to know how it works. We just need to know how to create it, and must be translated into machine code before they're run, because hardwares only understand low-level language. The way that we can convert from high level to low level is using translators. So we have two different translators: compilers, which translate every line of code in a program into machine code and runs it afterwards, and it produces a executable file at the end. Program can be run again without recompiling because you just run the executable file, and these can also be distributed, meaning all users will not see the source code. So interpreters translate one line of code and run that line. So one line it runs, then second line it runs, then third line it runs. Compilers basically do the whole thing at once. These do not produce an executable file, and these need to be running the program again needs to be interpreted to retranslate every line of code. These are non-executable. You would need to share the source code to distribute the program. And here's a question. The same language can be used on computers that use different hardware. That is high level, because you don't need a specific hardware to run it. It allows the user to directly manipulate memory. High level can't do that. That would be low level. It allows the user to write English-like words. So that is going to be high level because we have English words like while, if. And the last one is it always needs to be translated into object code or machine code. That's high level. So the only one that's low level is manipulate memory. And the last final topic is IDEs. What's the IDE? It basically provides a platform or a tool that programmers need to write and test program in one place. There are 4 features. One, it provides a editor, which basically allows auto suggestion, modify the code that the chosen language, allows pretty printing, like some words are like in a different color. All that things is what it does. It also provides error diagnostics, tools to allow the programmer to find and fix errors, breakpoints, stepping, variable constant. This is all to do with like debugging. Then we have runtime environment. So it allows the programmer to run the code from within the IDE. So when you press run, it runs. That's basically runtime environment. And translators, basically it's a built-in translator. It converts high level to low level. And yeah, so hopefully this makes sense and you found this video useful. If you did, be sure to like, comment and subscribe. And if I've missed anything, let me know. If I make any mistakes, let me know. I'm doing all of this like basically live. Hopefully you found this useful. Best of luck to everyone doing their GCSEs. And yeah, let me know if this is useful. So yeah, I'll see you in the next one.